Today we're going to be talking about section 3.4, which is on systems and equations with three variables. Now we've already talked about systems and equations with two variables, x and y, but now what we can do is we can add a z in there. And so just like before we had an ordered pair, x, y point, now we have an ordered triple, x, y, z point. So again, just how they show up in the alphabet, x, y, z, is how they show up in an ordered triple. Now, if I have my lines that have x, y, and z in them, and they all meet at one point, that's just one solution. And you'll see an example of that right here. Okay? All three lines meet at one point. Next, if we have all three of our planes, x, y, z, that all meet at one line, that is going to be infinitely many solutions. So just like when we had two lines right on top of each other, it was infinitely many. Now, if all three planes, x, y, z, meet at one line, then that's going to be infinitely many as well. It's also the same if all three planes are right on top of each other, all equal to each other. Now the last set is when we have no solution, okay? When there's no points in common with all three planes. So you see some examples, like right here. Two of the planes meet at a time, but not all three. Right here, two of the planes are parallel, and one of them goes through both parallel. Still, not all three in common, so there's no solution to the three. And then also, if you have all three planes being parallel, that's not going to have a solution either. So let's look at an example right here. Okay, so it says solve the system of equations. Now here's an example. It says right here. It says the coefficient of 1 in the second equation makes y a good choice for elimination. Now you'll see right here, okay, I have y, and so I can look at these two separately, and then I can look at these two separately to eliminate y. And then you have an x and a z and an x and a z, in both of them left. And so then we can solve those ones. Now this is going to be a lot of work and it's going to be a lot to do, but we can get an ordered triple that has a solution. Okay? So I'm going to look at the first two lines first. That would be 3x minus 2y plus 4z equals 35. And I'm going to look at the next one, this one right here. But if I want to get rid of y and I have a positive 1y, I'm going to multiply everything by 2. So I get negative 8x plus 2y minus 10z equals negative 72. Okay? And so what I can do then is I can just add down. So 3x plus negative 8x is negative 5x. Negative 2y plus 2y goes away. And 4z plus a negative 10z is going to be negative 6z. And now positive 35 plus a negative 72 is going to be negative 37. Okay? So I have one equation left that has an x and a z in it. Now what I can do is I'm going to look at the second two, and I'm going to eliminate the y from that one. Now the first equation, since it's positive 1y, I'm going to multiply everything by 3. So I get negative 12x plus 3y minus 15z is equal to negative 108. And then I'm going to get 5x minus 3y plus 3z is equal to 31. And again, I can add down because I have a positive 3y and a negative 3y. So I can just add these down. And so I get negative 7x. Y's go away. Negative 12z is equal to negative 77. So now it looks like something we're familiar with two variables. And so what we're going to do there is we're going to say, okay, well now I just have this system, negative 5x minus 6z is equal to negative 37. And I have negative 7x minus 12z is equal to negative 77. So if I wanted to eliminate one of those variables, obviously what I can do is multiply the top, all of them, by 2, because then I have negative 12z, and then I have negative 12z on the bottom, and then z's will go away. So that's what I'm going to do. I'm going to multiply the whole top by 2. And so over here you'll see I have negative 10x minus 12z is equal to negative 74. And I have negative 7x minus 12z is equal to negative 77. And so you'll see that since I have a negative 12z and a negative 12z, I can't add, I have to subtract. So negative 10x minus a negative 7x is going to be negative 3x. Negative 12z minus a negative 12z goes away. And negative 74 minus a negative 77 is going to be a positive 3. And so you'll see I get negative 3x is equal to 3. Divide by negative 3, divide by negative 3, and you see x is equal to negative 1. Perfect. We have one of our answers. We know x is negative 1. Now what I can do is I can take this negative 1 and I'm going to plug it into one of my equations with an x and a z in it. That way I can find out what z is. So let's make our lives easy and let's pick this purple one right here. Okay? And so I put negative 1 in for x. So negative 5 times negative 1 is a positive 5 minus 6z is equal to negative 37. All I did was take negative 1 times negative 5 here, and that's how I got positive 5. I subtract 5 from both sides, and I get negative 6z is equal to negative 42. Divide both sides by negative 6, and I find that my z is equal to 7. So now I have an x of negative 1, a z of 7, and I can go back and take both of those and plug them into one of my original equations. And the one that we use the most common, that middle one, is probably going to be the one that we can figure out because y is all by itself in it. So let's do that right now. So we're going to take negative 4 times negative 1 plus y minus 5 times 7 is equal to negative 36. Alright, so we multiply through what we can, so we get 4 plus y, and then minus 35 is equal to negative 36. Okay, you'll see 4 and negative 35 together are going to be negative 31. I add 31 to both sides, and I get y is equal to negative 5. Okay, so I have all of my points. So x was negative 1, y is negative 5, and z is 7. So this right here has 1 point as its solution. Here's a couple guided practice problems that you can try now. Now we can talk about when we have no solution or infinitely many solutions. And so what we're going to do is we're going to look at an example of each of them. One today and one tomorrow. So the first one we're going to look at, example A. Now I look at this one and I first look at my first two equations. Now which variable can I eliminate? Well, if I look at those two right there, probably the easiest one to eliminate is by multiplying the top by 1 and the bottom by another. And so I'm just gonna look at the x's. And I'm gonna say, okay, I'll multiply the whole top by 4. So I get 20x plus 16y minus 20z is equal to negative 40. And I look at the bottom one and I'm gonna multiply that one by 5. And so I get negative 20x minus 50y, and then I get minus 40z is equal to 5 times 16 is going to be negative 80. And so you'll see I can just add down, and I see I get the x's cancel out. The y's become negative 34y minus 60z is equal to negative 120. Okay, so we got one equation that just has y's and z's in it. Alright, so let's look at the bottom equation now. And to eliminate one of those, maybe we'll do the same thing, but we'll multiply the top by 6. Or actually, we can multiply the top by 3 and the bottom by 2. That way I get 12x's. Okay, so I'll do that now. So I multiply the whole top by 3. I get negative 12x minus 30y minus 24z is equal to negative 48. And I multiply the bottom all by 2, and I get 12x plus 30y plus 24z is equal to 48. And you'll notice when I add down, okay, when I add down, x's go away, y's go away, z's go away, so I get 0 is equal to 0. And so that means that those two lines are actually the exact same. They're right on top of each other. Or those two planes, excuse me, are right on top of each other. So if I have this one equals 0 and this one equals a line, it means that the two of the planes are the same, and they connect with one of the other planes right at a line. So this is going to be infinitely many solutions. So when we have two lines that are the same, they're going to be infinitely many solutions. Try letter 2B now.